Howdy, this is your friendly neighborhood physics teacher here, and we are going to talk about the Newton's Cradle demo station. And so we have the Newton's Cradle right here. And if we can get it in the screen, there we go. So basically what you're supposed to do with the Newton's Cradle is, one, get it to stop moving, and then you're going to pull back to a certain height and let it go and see what happens. Sit there and watch it. It goes for quite a while. And eventually it will come to a stop. Same thing, and you can do the same thing with 2. Pull 2 back, see what happens. You get kind of crazy. You can pull 3 back and see what happens. So in this lab, you were supposed to think about, put it into words. So you're supposed to put it into words, and you're supposed to put it into equation. If you can get the equation, you can get it into words, or vice versa. So a couple of things to think about. I'm going to turn off that now. So I'm just a voice now, you don't see me. Ooh. Okay. So when you have your Newton's Cradle, it's basically Newton's Cradle is a pendulum. And so when it's all the way up here, you're adding potential energy to it. So this is going to be gravitational potential energy, and this is going to be the max gravitational potential energy. Now, as it starts moving down, the gravitational potential energy starts being converted into kinetic. So it has gravitational and kinetic until it gets to the bottom. Let's have a few extras here. Until it gets to the bottom. And that's where okay. And they should be touching. Okay. So once it gets to the bottom here, right when it hits. So I'm going to right when it hits, we're going to have our max kinetic energy. So far, all these are equal to each other. It's an even transfer. Max gravitational starts turning in from gravitational into kinetic, and we have max kinetic. As soon as it hits, you're going to take that max kinetic and you're going to subtract some type of work. So work done by friction, work done by sound, anything like that. You're going to have some type of work that's being taken out of the system. And also, it's going to lose energy as the energy passes through all the balls there. So you have energy is going to be losing as it's passing through. Now, eventually, it will start moving again. It's going this way. It's going this way. And then you'll have one of them to go here. So again, as it's moving up, you have kinetic energy. It's getting converted into, hold on, even before that. So all that does go into kinetic energy, but it's not max. So right here again, right there, we'll have kinetic energy, but it's not going to be the same because we lost some work. Then all that kinetic energy is going to get converted into gravitational, which then eventually would equal gravitational. And the process continues. So you go from gravitational to moving to kinetic to losing work, and in the process just keeps going back and forth, back and forth. But that's the one big long equation. Think about it in parts. So focusing at the top, what's happening at the top? What's happening as it's moving? What happens right before it hits? What happens as it hits? What happens right after it hits? What happens as it's moving? What happens at the top? So you kind of get that. Yes, it's a really long equation, but you kind of see what's happening there. And anytime you're going to have a work, you're going to have a greater than or less than sign in your equation. And so from there, you can put it into words. The only thing that little extra you would need to do is right here, where it would go into what's that work. Well, that work is like sound. That work is friction, doing thermo and stuff like that. So that's where the little bit of extra words we'll need to do in your explanation. But here, just say it has gravitational max. Why? It's getting converted from gravitational to kinetic. Why? Like stuff. So as you're going with your paragraph, make sure you say why. So hopefully that helps with the Newton's Cradle. If you have any questions, please ask. Have a wonderful day. Bye.